Welcome to our latest video lesson, and this video is on the topic of using electrolysis to extract metals. By the end of this video lesson, you should be able to understand that molten ionic compounds conduct electricity and can be split up by electricity in a process called electrolysis. You should also be able to explain how electrolysis works and be able to name the products forming in each electrode. And you should be able to write equations to describe what is happening at each electrode and classify this as either oxidation or reduction. In previous video lessons, we've talked about the relationship between the reactivity of a metal and the ease at which it can be extracted from a metal ore. And we've learned that metals at the top of the reactivity series are the hardest to extract. Now, in this video lesson and in upcoming video lessons, we're going to focus on these very reactive elements, and we're going to talk about how they can be extracted from their metal ores using a process called electrolysis, where we use electricity to split up a compound into its constituent elements. In previous video lessons, we've also discussed two ways where metals can be extracted from metal ores. The first is by heating the metal ore with a reducing agent, a chemical that removes oxygen from the ore. So, as you see in this slide, we have lead oxide reacting with a reducing agent, carbon, and we make lead and carbon dioxide, and the carbon has removed the oxygen from the lead oxide. And that's why it's classed as a reducing agent, because reduction means a loss of oxygen. In our previous video on reducing agents, we looked at how copper can be extracted from copper oxide by heating with charcoal. And in our recent video on the blast furnace, we learned that iron can be extracted from iron ore by heating with carbon in the form of coke, where our reducing agent is carbon monoxide. In previous video lessons on this topic, we also discussed displacement reactions, and we learned that you can extract a metal by heating a metal ore with a more reactive metal, because the more reactive metal kicks out the less reactive metal from the metal compound. So here we have aluminium reacting with iron oxide. Aluminium is more reactive than iron, so kicks it out, and therefore leaves us with aluminium oxide and iron. And we've extracted the iron by heating the metal compound with a more reactive metal, in this case aluminium. In this video lesson, we're going to look at how we use electrolysis to extract metals. And the metals that rely on electrolysis for extraction are the most reactive metals. It's not safe for us to try and extract very reactive metals using displacement reactions. It's not safe for us to use more reactive metals to extract very reactive metals. So therefore, we need a different technique. And the technique we use relies on electricity breaking up compounds into its constituent elements. Now, electrolysis, as I said, is used for very reactive metals, and electrolysis is the process where we split up a compound using electricity. And to conduct electricity, we have to have ionic compounds. These are compounds made up of a metal and a non-metal. And ionic compounds conduct electricity when you melt them or you dissolve them in water. Now, some students may have come across electrolysis previously if they've ever carried out electroplating experiments. In an electroplating experiment, you would coat an object with a thin layer of a metal, and previously you may have done experiments where you've coated a coin or a key with a thin layer of copper. Now, electroplating is used to stop materials corroding and also to make them more attractive. To carry out electrolysis, you need compounds that conduct electricity, and the types of compounds that conduct electricity are called ionic compounds. Now, ionic compounds consist of a metal and a non-metal. So, for example, sodium chloride. Sodium's a metal, chlorine's a non-metal. Copper oxide. Copper's a metal, oxygen's a non-metal. In our previous series of videos on the topic of bonding, we discussed ionic compounds and ionic bonding in great detail. However, it is useful to recap some of the main features of ionic bonding to help you understand how electrolysis works. Ionic compounds involve metals and nonmetals, and they're formed when the metal loses electrons and the non-metal gains them. So in this bonding diagram here, we have sodium that has 1 electron in its outer shell and chlorine that has 7 electrons in its outer shell. And the sodium gives its 1 electron to chlorine. And the reason they do this is because the sodium and the chlorine are both looking to gain a full outer shell of electrons, which is a very stable arrangement. When sodium loses an electron, it forms a positive ion, Na+. And when the chlorine gains an electron, it forms a Cl- ion. And in sodium chloride, there are no molecules. Sodium chloride just exists of billions and billions of pluses and minuses all joined together in a giant structure. And this giant structure is called a crystal lattice. Now, in a crystal lattice, there are very strong electrostatic forces. Every Cl- ion is held tightly with lots of Na+ ions attracting it, and likewise every Na+ ion is surrounded by lots of Cl- ions, so the structure is very strong. Now, sodium chloride, when it's a solid, doesn't conduct electricity. But when you melt it or dissolve it in water, the lattice breaks down and the ions are free to move. And when the ions are free to move, the compound conducts electricity. So to conduct electricity, you have to have ions, positive particles and negative particles, and they have to be able to move about. So that's why when you do an electrolysis experiment, you have to have the ionic compound either dissolved in water or molten. Now if we look at this slide, you see different pictures to represent what a lattice looks like. Now the key thing that we have to remember is that the forces within a lattice are very strong because we've got billions and billions of pluses and minuses all stuck together. And that means if you want to melt an ionic compound to get it to conduct electricity, it requires a lot of energy, a lot of heat. And that can be very expensive if you're extracting a metal, because you may have to heat up the compound to temperatures of around 1000 degrees C to get it to melt. And that obviously makes it much more expensive to extract the metal. Now on the back of the exam paper, you get this table of the different ions that exist. So for example, if you have asked a question about aluminium oxide, you should be able to use this table and understand that aluminium oxide consists of aluminium ions with a formula Al3+, and oxide ions with a formula O2- ions. Likewise, if you were asked a question about potassium chloride, you should see from the table that the 2 ions present in potassium chloride are K+ and Cl- ions. And that's how you use this table. You use this table to understand what ions are present in the different ionic compounds. The other thing to get from this table is that metal ions are positive and non-metal ions are negative. Now the only exception to this really is hydrogen, because hydrogen is a non-metal that can form positive ions. And that's because hydrogen is atomic number 1. It has 1 electron in its outer shell and therefore can react by either losing an electron, forming a H+ ion, or gaining an electron, forming a H- ion. Even it predominantly forms H+ ions. So now let's look at how electrolysis works. And the first thing we're going to look at is the apparatus that we would need to carry out an electrolysis experiment. So the pictures here show how you could go about doing an experiment. You would need a power supply, and you would need connecting wires, and you would need 2 electrodes. Now, they usually use graphite electrodes to carry out electrolysis because graphite has a high melting point, is unreactive, and is a good conductor of electricity. But you could use metal electrodes as shown in the diagrams here. Now in these diagrams, the electrodes are dipped into an ionic solution, an ionic compound dissolved in water. However, we're going to focus in this video on molten ionic compounds that have been melted. So if you were going to carry out an experiment using a molten ionic compound, you would need to keep heating this solution with a Bunsen or an electrical heater to make sure that the ionic compound is kept in a melted state. Because remember, ionic compounds only conduct electricity when they're molten, when they're melted, or dissolved in water. Now in this excellent video clip from the Royal Society of Chemistry, you can see how you would carry out an electrolysis experiment. Now what we're doing here is we're putting molten zinc chloride into a crucible, and dipped into the crucible are 2 graphite electrodes, and the crucible is held on a pipe clay triangle on a tripod, and the Bunsen is heating up the crucible. The zinc chloride is melting, and when it starts to melt, the ionic compound conducts electricity, and that's why there's a reading on the ammeter. And as soon as it starts conducting electricity, the zinc chloride starts breaking up into zinc and chlorine. Now you can test for the chlorine gas by using some damp litmus paper, and the litmus paper initially starts to go red because chlorine is an acidic gas, and eventually will go white because chlorine is a bleach. Now if we cool down the crucible, and we can do this by dipping it in some water because that will actually get rid of the unreacted zinc chloride, you're left with zinc metal. So our 2 products are zinc and chlorine. So now we've seen an electrolysis experiment in action, we're now going to go through the theory of electrolysis. So if you have a power pack or battery connected up to your 2 electrodes, and that is dipped into an ionic compound that is molten or dissolved, that ionic compound conducts electricity, and it can be broken down by the electricity. And the ionic compound consists of positive ions and negative ions. And when the power supply is turned on, electrons will flow onto the negative electrode, because remember, electricity is a flow of electrons, and positive metal ions are attracted to the negative electrode. So for example, if you had copper oxide, the Cu2+ ions would be attracted to the negative electrode. When they're attracted to the negative electrode, they pick up electrons from this electrode, and they use these electrons to form the metal. So copper 2+ would gain 2 electrons to form copper metal. Now the negative electrode is called the cathode, and metals always form at the negative electrode. So copper 2+ ions are attracted to the negative electrode, they pick up electrons from that electrode, they gain electrons, and they form a metal. And on that electrode you would see brown copper forming at this negative electrode. Now in ionic compounds, you don't just have positive ions, you have negative ions. And if this ionic compound is melted or dissolved in water, these negative ions can move about just like the positive ions. And the negative ions are attracted towards the positive electrode. Now we call the positive electrode the anode. And if we had, say, copper oxide or copper chloride, the oxide ions or the chloride ions would be attracted to the positive electrode. And when non-metal ions are attracted to the positive electrode, they form non-metals. So for example, the chloride ions would be attracted towards the positive electrode and would ultimately end up forming chlorine gas. And the oxide ions would move towards the positive electrode and ultimately form oxygen gas. Now, these negative ions, when they move towards the positive electrode, they lose electrons. Now, the reason that these negative ions have a negative charge is because they have more electrons than the corresponding atoms. For example, Cl- ions have one more electron than a Cl atom, and an O2- ion, an oxide ion, has 2 electrons more than the corresponding oxygen atom. So when these negative ions move towards the positive electrode, they lose these extra electrons to form non-metals. And these electrons then flow from the positive electrode to the power pack and complete the circuit. So you have to remember that metals form at the negative electrode, the cathode, and non-metals form at the positive electrode, the anode. So this table illustrates this point because we have 5 compounds, and you can see that the 5 compounds are split up into their corresponding elements, and the metals form at the negative electrode, the cathode, and the non-metals form at the positive electrode, the anode. So copper oxide is split up into copper and oxygen. Copper forms at the negative electrode, the cathode, and oxygen forms at the positive electrode, the anode. So in our second example, we have sodium chloride. Sodium chloride splits up into sodium and chlorine if we're dealing with molten sodium chloride. And the sodium forms at the negative electrode, the cathode. The chlorine forms at the positive electrode, the anode. If we have lead bromide, that splits up into lead and bromine. Lead forms at the negative electrode because metals form at the negative electrode, and bromine forms at the positive electrode. If we have aluminium oxide, we have aluminium forming at the negative electrode, that's the metal. We have oxygen forming at the positive electrode, and in the case of zinc fluoride, zinc forms at the negative electrode and fluorine forms at the positive electrode. So the key things to remember: metals form at the negative electrode, non-metals form at the positive electrode. To help our understanding, we're now going to look at a few specific examples. So let's start with lead bromide. Now lead bromide is made up of Pb2+ ions and Br- ions, and if we have our 2 electrodes dipped into molten lead bromide, electrons flow from the power pack onto the negative electrode. The Pb2+ ions move towards the negative electrode and they pick up electrons. Now Pb2+ means that it has 2 less electrons than the corresponding lead atom. So it picks up 2 electrons from the negative electrode and forms lead metal. So we would see grey lead forming at the negative electrode. The Br- ions move towards the positive electrode, the anode, and they have 1 more electron than the corresponding bromine atom, and they lose electrons to form bromine gas. So my 2 observations would be a grey metal forming at the negative electrode, and that would be lead, and I would get bubbles of gas forming at the positive electrode, which would be bromine gas. So we're now going to look at how we would represent the processes occurring at each electrode with electrode equations. So lead is made up of Pb2+ ions and Br- ions, and the Pb2+ ions are attracted to the cathode, the negative electrode. So at the cathode, the Pb2+ ions are gaining electrons. They're taking electrons off the negative electrode and they're using them to form lead metal. So Pb2 plus 2 electrons makes Pb. Now if I've done this right, the charge is balanced as well. So I've got 2 plus, 2 minus, cancel out, neutral. And on the right hand side of the equation I've got Pb, that's also neutral. Now at the anode, the positive electrode, I have Br minus ions, and each Br minus ion loses 1 electron to form a Br atom. Now I've got to remember that bromine doesn't exist as atoms, it exists as bromine molecules because it's a group 7 element. So therefore I need 2 Br minus ions, and they're going to lose a total of 2 electrons to form bromine molecules. So now we're going to look at a second example. So if we have potassium chloride is made up of K plus and Cl minus ions, and the K plus ions are attracted to the negative electrode. At the negative electrode, they gain electrons to form potassium metal, and the Cl minus ions are attracted to the positive electrode, and the Cl minus ions lose electrons to form chlorine gas. So if I do electrolysis of molten potassium chloride, my two products are going to be potassium and chlorine. So now let's have a go at writing the electrode equations. So if we had potassium chloride, we've got K plus ions and Cl minus ions. And at the cathode, the negative electrode, we have K plus ions being attracted, and each K plus ion gains 1 electron. It takes 1 electron off the electrode, and when it gains an electron, it forms potassium atoms. So I would get potassium metal forming at the negative electrode. And at the anode, the positive electrode, Cl minus ions are attracted. And the Cl minus ions, remember, have 1 more electron than a chlorine atom. So they lose that electron to form Cl. But chlorine, just like bromine, is in group 7, so it goes round in pairs. So it's Cl2. And therefore, if it's Cl2, I need 2 Cl minus ions, and they lose a total of 2 electrons. So that would be my final electrode equation. So I would see grey potassium metal forming at the negative electrode and bubbles of chlorine gas forming at the positive electrode. So we're now going to look at one final example, aluminium oxide. So aluminium is made up of Al3 plus ions and O2 minus ions. And at the negative electrode, the cathode, the Al3 plus ions are attracted, and Al3 plus ions are attracted to the negative electrode, they're attracted to the cathode, and when they're attracted to the cathode, they gain 3 electrons. Now it's 3 electrons because it's Al3 plus. So when they gain their 3 electrons, they make aluminium metal, and you can check that it's right because the charges cancel out, 3 plus 3 minus, neutral on the left, neutral on the right. And at the anode, the positive electrode, the oxide ions are attracted, so it'd be O2 minus. Now remember, O2 minus means it's got 2 more electrons than a normal oxygen atom, so it would lose those 2 electrons to form an oxygen atom. But you've got to remember that oxygen doesn't exist as atoms, it exists as molecules. So I need O2, so therefore I need to times the left hand side by 2. So it becomes 2 O2 minus 4 electrons makes oxygen gas, O2. Now in these examples, we've seen the positive metal ions being attracted towards the negative electrode. And when they're attracted towards the negative electrode, they gain electrons and form metals. We also see the non-metal ions, the negative ions, being attracted towards the positive electrode. The non-metal ions, the negative ions, lose electrons to form non-metals. Now we're seeing a gain of electrons and a loss of electrons. And in chemistry, the term that we use for a loss of electrons is called oxidation. Now this term we've also used when describing a gain of oxygen. It can mean both. Oxidation means a gain of oxygen, but when talking about electrons, it means a loss of electrons. Reduction means a gain of electrons. It also means a loss of oxygen, but if you're talking about electrons, reduction means a gain of electrons. Now the way we remember this is oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So if we look at the two equations here, we have Na plus ions being attracted to the cathode. Na plus ions gain electrons to form Na, and this gain of electrons is reduction, because reduction is a gain of electrons. And if you want to know why it's called reduction, well, notice that the Na has a 1 plus charge and then it has no charge, so the charge has been reduced. That's why it's called a reduction. Reduction is a gain of electrons. At the anode, the Cl- ions, they lose electrons to form chlorine gas. And the loss of electrons is oxidation. Now, on this slide, we represent the two Cl- ions losing 2 electrons slightly differently. Notice we've moved the electrons to the right-hand side here. That's absolutely fine to do this, or we could have left it on the left-hand side. So we could write down 2 Cl- ions minus 2 electrons makes Cl2, or we could write it like they've done on this slide, which is 2 Cl- ions goes to Cl2 plus 2 electrons. Equally fine to do either way. Now in all these examples, we've effectively removed a metal from a metal compound. We've extracted a metal from a metal compound or a metal ore. So now let's test your understanding of electrolysis with some practice questions. So here's question 1. It's about the electrolysis of nickel bromide. Now nickel bromide is made up of Ni2 plus ions and Br minus ions, and we want you to name the products formed at the negative electrode, write an equation to represent the formation of this product, and then name the product formed at the positive electrode and write an equation to represent the formation of this product. So pause the video and have a go at question 1, and then we'll go through the answers. So if we go through question 1, we have nickel bromide, so we're made up of Ni2 plus ions and Br minus ions. Now they may not give you this in the question, but you would have the table of ions at the back of the exam paper. So at the cathode, the negative electrode, I would have Ni2 plus ions being attracted to this electrode, and each Ni2 plus ion would gain 2 electrons and form nickel metal. So my product of the cathode would be nickel metal. My observation would be a grey solid forming. And at the anode, the positive electrode, I would have Br minus ions being attracted, and the Br minus ions would lose electrons to form Br. Now remember, bromine is a group 7 element, so it exists as Br2, it's diatomic, so I would have 2 Br minus ions losing 2 electrons to form Br2. So now have a go at question 2. So question 2 is about the electrolysis of molten potassium oxide. So for part A, name the product formed at the negative electrode, the cathode. Then for part B, write an equation to represent the formation of this product. And then part C, name the product formed at the positive electrode. And part D, write an equation to represent the formation of this product. So pause the video, have a go at the question, and then we'll go through the answers. So now let's go for the answers to question 2. So potassium oxide is made up of K plus ions and O2 minus ions. We get these from the back of the exam paper if they're not listed in the question. Now at the cathode, the negative electrode, we have K plus ions being attracted to this negative electrode, and the K plus ions are attracted to the negative electrode, they gain an electron and they form K atoms, potassium atoms. And remember, when they gain electrons, that is called reduction. Now at the positive electrode, the anode, we have O2 minus ions losing electrons to form oxygen atoms. And remember that oxygen is O2, so that means that we have to times everything by 2. So it would be 2 O2 minus ions minus 4 electrons gives you O2. So O2 minus 4 electrons gives you O2, and that would be oxidation, a loss of electrons. So now attempt question 3, which is asking you about the electrolysis of molten magnesium fluoride. Once again, we'd like you to name the product formed at the negative electrode, write an equation for this, and then name the product formed at the positive electrode and write an equation to represent the formation of this product. Pause the video, have a go at the question. So let's go for the answers to question 3. So magnesium fluoride is made up of Mg2 plus ions and F minus ions. The Mg2 plus ions are attracted to the negative electrode, the cathode. And when Mg2 plus ions are attracted to the cathode, they gain 2 electrons. They gain 2 electrons because remember it's Mg2 plus. So they gain 2 electrons to form Mg, to form magnesium. That is reduction. Reduction is a gain of electrons. Now the F minus ions are attracted to the anode, the positive electrode, and an F minus ion will lose an electron to form a fluorine atom. But fluorine is diatomic, it exists as F2, so I need to times everything on the left by 2, so it's 2F minus 2 electrons gives F2. That is oxidation. So now attempt our final question. We're asking you to look at the electrolysis of molten calcium iodide, and once again name the products forming at the negative electrode, write an equation to represent this, then name the product formed at the positive electrode and write an equation to represent the formation of this product. Pause the video and have a go at the question. So now let's go through the answers. So calcium iodide is made up of Ca2 plus ions and I minus ions. The cathode, remember, is the negative electrode, and calcium ions are positive, so they're attracted towards the negative electrode. So our equation would be Ca2 plus, it would gain 2 electrons because it's Ca2 plus, and it would gain them to form calcium atoms. Ca2 plus 2 electrons goes to Ca, and at the anode we would have I minus ions being attracted, and an I minus ion loses an electron to form I. Iodine's a group 7 element, so it exists as I2. So I have to times everything on the left by 2, so it becomes 2I minus 2 electrons makes I2. Now that is oxidation because it's been a loss of electrons. So that concludes our video lesson. All we need to do now is go over our lesson objectives. So after watching this video, you should understand that molten ionic compounds conduct electricity and can be split up by electricity in a process called electrolysis. You should be able to explain how electrolysis works and be able to name the products forming at each electrode. And you should be able to write equations to describe what is happening at each electrode and classify this as either oxidation or reduction. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.